The photoelectric effect shows this thing. The number of electrons emitted from the emitter plate that depends only on the intensity of the incident radiation. It have nothing to do with frequency of the incident radiation. The maximum kinetic energy with which electrons are emitted means the energy of the emitted electrons that depends only on the frequency of the incident radiation. It have nothing to do with intensity of the incident radiation. And this particular phenomenon, that is instantaneous one, that is instantaneous one. Now see here the controversy. It was established the light has a wave nature, okay, and according to the wave theory of light, energy and intensity are associated with each other, and it depends on the amplitude of the wave. We give the definition of intensity of the wave like this: the amount of energy passing through any surface per unit area per unit time normal to it, that is called its intensity. Okay, so if intensity is more, then that particular light is more energetic. But here we observe different thing. Experimental results shows this thing: photoelectrons emitted with energy that does not depends on the intensity of the incident light. And wave theory says this thing: energy and intensity are associated with each other. And as per wave theory, frequency have nothing to do with energy of light. But here experiment shows this thing: the frequency is associated with energy. Okay, energy of the photoelectrons depends only on the frequency, because as frequency changes, energy changes. This thing can't be explained with the help of wave theory. Second thing, photoelectrons are emitted immediately on making light incident on the metal surface. Okay, actually electrons within the metal are under the effect of certain forces, and we must supply some energy to it. But if we consider the wave nature of light, then that wave when incident on the metallic surface, then as the amplitude of it absorbed, the energy is absorbed by the electron. So when in this process electron absorb the sufficient energy, then after it will be emitted. It implies that as per the wave nature of light, when the light incident on the surface and electron is emitted, in this process there must be some time difference. There must be some time lag. But here experiment shows this thing: this phenomenon takes place instantaneously within the time interval of 10 raised to minus 9 seconds. The electron is emitted. Okay, then as per the wave theory, if less intense light means dim light, that is a weak light. But if the light is dim, it is with very less intensity, but if the frequency is a sufficient one, means equal to threshold frequency or greater than that, electrons are emitted. Clear? But wave theory says this thing: if dim light is there. If light is with very, very less intensity, then this phenomenon can't take place. It implies that, in short, we can conclude like this: the wave theory totally failed to explain this photoelectric effect. And how can you deny the wave nature of the light? Because with the help of the wave nature of light, one can explain the phenomena like interference, diffraction, polarization, all these things. And experimentally, you can observe these particular phenomena just like this photoelectric effect. So you can't deny that wave nature of light also. So this one was the biggest controversy in those particular days. Clear to all of you?